Alright, welcome back. We're going to be working with a new part today, and it's a buzzer, so we'll be making a lot of noise. Before we get started, got our little cat here. We're going to give a little squeeze. Alright, I think I'm good to go now. I'm going to switch screens, and I've got this little animation of a speaker, and you'll notice that it's vibrating back and forth. And this is sort of the basic mechanics for how to create sound. We have to have a part that is physically moving back and forth. So that would be this solid inner ring here, and then this it's attached to this sort of a flexible material. And then we have an electromagnet that will turn on and off, a magnet that we can control. And when we turn it on, it's going to attract this metallic rim here, and then when we turn it off, the rim is going to not be pulled in some direction. And by turning that electromagnet on and off lots of times really fast, we can get it to vibrate like this. And the more vibrations we get, or the slower the vibrations, we can get different sounds that come out of our speaker. I want to show you, I just did an image search for speakers, and there's lots of variety of speakers, but each one has a basic fundamental mechanism for making that sound. That's little vibrating parts. We're not going to be using these. We're going to be using buzzers, which look like these. And the ones we're going to use actually look like this one here. I've actually got it in my hand. I'm going to switch back to this view so you can find them in your kit. There's actually two of them. One looks like this, one looks like this, and you're probably saying they look absolutely identical, except for the piece of tape on the top of one, a little sticker they put on one. I recommend you leaving that on there. It'll make it easier to distinguish these two. And on the back, one has like a little wax covering, and the other one is clear, and you can see some of the circuits in there. They have different names. One is called active, and the other is called a passive buzzer. But what we're going to do is we're just going to try them both out and see how they compare. But inside, we're going to have still the same process is going to be occurring. We're going to have something vibrating back and forth. All right, I'm going to put these aside. So all you need are the buzzers. These buzzers do have a positive and negative side, just like our LEDs. But if you look closely at them, they're clearly marked. One side, we got two wires coming out the back, and one side is clearly marked as a positive with a big plus on the top of the buzzer. The other one, actually underneath too, you can see, if you look underneath one leg, you can see marked positive, the other side will be marked negative, so we got to make sure we're aware of that. And on the other one, underneath it's not marked, but on the top where the sticker is, it says positive. So probably another reason to leave the sticker on, so it'll tell us which side is positive. And let's just go ahead and actually build this circuit. So let's switch to this view. Maybe make this a little bit bigger. Maybe a little bit bigger than that. And I'm going to get rid of this and open up this. Alright, so we're ready to go. I noticed, just dropped it there. I noticed that the spacing, and I gotta leave this down here so you can see what I'm doing. If I just try to go directly, doing pins that are directly across from each other, I can't quite get the buzzer to go in. So I found that if I actually tilt it just a little bit, so I am not putting it in J7 and 10, I'm actually tilting it so that's in I7 and J10. It actually will fit in there easier, like that. Same thing with the other one. It just doesn't quite want to straddle all those. Actually, that one is doing a lot better than the other one. That one's okay, but it's even still easier if I tilt it just slightly. Maybe one more. Actually, my legs is bent already. Let me bend it back. I'm going to bend it in actually. Maybe that will help a lot. And I'm going to put the positive side towards the top here. So, alright, there we go. So I've got the, let me find something to point with. I'm going to point with this little resistor here. So on this side I got the positive, and since I can't see my legs, I'm not really sure which holes they're in. So I'm going to pull it back out again and tilt it, and notice that I'm actually occupying 2 empty spaces in between where my buzzer is going in. So I'll have it in 9, 2 empty spaces, then it'll go into 12 on mine. So this is a good spot for a wire. This and this one, there's nothing there, and then this is the other leg. So this is going to be the positive side. We're going to send this side, I'm going to use a red wire, and we're going to use this side. If I mess this up, we can just fix things. We're going to use pin 2, and the other side of our buzzer, which is over here, we're going to send that to ground, which is way over there. So I crossed wires a little bit, that shouldn't be a big deal. And that is actually all we need. So this is probably one of the simplest wiring that we've done in class. You don't need a resistor. And we'll swap these out as we do write some code for this, but we'll put this right to the side here and let this hang out. Now we're going to go to our code, so I'm going to actually plug this in and get this all set up like that. And there we go. That looks pretty good. Alright, now let's actually shrink this just a little bit so you can see things, see the code a little better since we're done with the build. And give ourselves a little space. I'm going to get rid of these comments. Alright, so as I mentioned before, in order to get a buzzer or speaker to work, we've got to vibrate something back and forth. And we're going to accomplish that, at least the first way to accomplish this, is simply by sending in a voltage into the buzzer. We're going to send a high and then a low and then a high and then a low. And we've done this before. We did this with the LEDs. So the code is going to look very similar to the stuff we've already done before, which is a good thing, I suppose. So let's do that part. Digital write. We're going to use pin 2. I don't think we need to declare anything. I'm just going to leave it as, we could come up here and say buzzer pin equals 2, and then put buzzer pin for 2 right here. But I think that's actually going to be a waste of our time. So we're not going to declare that. We're just going to leave it as a 2. I think this would actually be less time. And then we want to turn it on. So we're going to basically turn that electromagnet on temporarily, and it's going to pull something towards it. And then we got to turn it off. After a little bit of time, we want there to be a little bit of time in the middle. We're going to leave that blank just for now. We're going to go back, if I can spell it right, digital write to low. So that looks good. And then delay. Whoop, I said not to put anything in there, and then I just put something in there. Alright, I want to just pause for a minute. Actually, while I'm remembering to do this, let's do our pin mode. Let's tell the program that we want 2 to be an output, so it knows to send something out of pin 2. We're going to send a high, and then right after that we're going to send a low. So we're turning on the electromagnet by sending some current to it, and then we're going to turn it off. So we're going to turn the magnet off, and then that's going to cause something inside to move back and forth. Alright, so my delay is kind of critical here. I'm just going to actually throw in a value. Let's just throw in like 100. Do a little experiment here. And I'll show you the problem we're going to have to work around, which is simple, but I'm going to start with this. Let's go to our tools again. Everything's set up automatically for me. You may need to make some adjustments there if it did automatically set yours up. I've been using this morning, so I kind of remembered what I was using. So let's upload that. Let's call it buzzer 3. I was toying around with buzzers earlier. Alright, that looks good. And the sketch is, we're waiting a little bit here, waiting for that bar beyond my head to finish. Looks like we're being a little slow. Hey, how about that? Right off the bat. Now that's going to get a little annoying, so I'm going to pull the ground out and break the circuit so I don't hear that all day long. And there's a simple buzzer. Alright, now the control of this buzzer is all in the delay. And we have options here. We can just manually put different numbers here. Matter of fact, let's just go ahead and do that. Let's just put 100 in here. And notice when I put the ground back in, I'm going to get the original annoying noise. Actually, it's not too annoying. Oh, I put it in the wrong pin. Or did I? No, the wrong pin. There we go. So I changed the delay time. And we get this long, same pitch, but now it's lasting longer, right? It's also getting quite annoying to hear that. And so let's pull that out. We have some options here for our delay time. But before we get to messing around with delay time, I'd like to be able to control what's happening a little bit easier instead of having to constantly upload or pull out the wire here. That is kind of annoying to me. I would like to be able to just input some values, and we've already learned how to do that. So let's just add a couple lines of code, and it'll allow us to keep everything running. We don't have to keep changing things. So we're going to turn on the serial monitor. Everything I'm going to do you've seen before. So that sets the baud rate and turns it on for us. Now I need to send a little message to the user, tell them what's happening, what I want from them. Let's say enter in, let's do delay time. Since the delay time is going to be what modifies, what am I doing? Delay, I'm talking and typing at the same time. Let me finish typing first. So enter in delay time. So it's the delay time that's going to be controlling what our buzzer does, the sounds it makes. So that looks pretty good. Now we need to lowercase w, not an e. There we go. Now we need to tell the computer or our program to wait. We've seen this before. Alright, so this line, just a reminder, basically it's a while loop, and inside of here we're telling the program to wait and don't do anything until the user inputs something. So when this becomes falsified, then it's going to jump out of this loop. Now in these brackets right here, there's nothing in there. Let's move this down so you can see. Normally we'd put something in here if while you're waiting, do this other thing, but we just wanted to wait. We don't want to do anything other than just stop the program from progressing. So we're leaving those brackets blank. And you can actually modify this part right here. You can change it around to wait until certain conditions occur. We're just going to leave it like this because this works great for what we're doing. And now we need to store what the user gives us. They're going to give us a number. So let's call it user input. And now the program won't know what this new word is. The statements that it recognizes, as you know, they always change colors. And this is not changing color because it doesn't recognize it. So up here at the top, we have to declare this variable and use this data type of integer. It'll work for us because we just want to input for our delay time. We're going to input an integer. So we're going to call it user input. And we got to be very careful about how we spell this, so it's exactly as what I've used down here. Alright, so now the computer knows to recognize this as an integer. Expect an integer value for user input. Alright, so what are we collecting? How do we collect this information? We're going to use serial. We've used this before as well. Serial.parse, which means to read it. And read what? Read the integer and store it as the user input. Alright, so we're asking the user what we want from them, and then we're going to wait until they input something, and then we're going to store that as user input. And then we want to put that in here. That is going to be our delay time for turning this on and off. Okay, so let's give this a try, and we'll see that we're probably going to make one more modification, but I'm going to stop right here so you can see what happens. Maybe you can predict what happens with this setup that I've got. Okay, so it says it's done, and alright, asks us our question, which is blocked by that view over there. I'll move it over just a little bit so you can see. That looks pretty good. Actually, we don't need this much anymore. So let's just go with that. Let's enter in, let's go back to what we used before, which is 100. And I don't hear anything. I don't know if you didn't hear anything. Let's try 1,000. We also tried 1,000. Let's try that. And I still didn't hear anything. Let's try 2,000. We're advancing to new lines, so it's going through this, but I don't hear anything, right? Well, part of the reason is my ground wire is not plugged in. So let's give it another try. And notice this time we got one beep regardless of what delay I use. Okay, so it's going through this one time and then that's it. And it's jumping back to asking me enter in delay time, which is maybe all we want. But I would like to actually put in, actually let's do one more thing. Let's switch, I don't get too far into this. I don't want to forget our little friend over here, the other buzzer. Let's switch these and do a little comparison. And pull that one out. Got to make sure the positive is going to pin 2. So let's go ahead and do that. There we go. We don't need to upload anything since we're just changing parts out. We'll open this. If we wanted to, though, we could clear this, clear the output, but then we would have to hit the button on our Arduino to restart our program. And let's go ahead and go through our little series of numbers we put in here. Ooh, I barely heard that. Let's try 1,000. Can barely hear these. Very quiet, but it's only giving us just a short click, right? Okay, so for this buzzer, we're going to need to make a little modification to help it out a little bit. And let's just exit out of that. There's one more thing I want to point out to you as well. These buzzers really like to go on and off pretty fast, particularly what I just put in there. So we can change our delay time. Instead of being in milliseconds, we can actually do something like this and do microseconds. And just put that in here. So it's still a delay, but now it's 1,000 times faster than just a normal delay. And we should actually just leave it like this. Now let's input one more thing. We stop for every single change. We won't be able to take this. We'll have an hour video. So what I wanted to put in here, we've used some for loops before. So what's happening is we're going through here at one time, and then it's going back to the top. But I like to have this operate and go on and off for a little while. So let's put in a for loop so that we can have it get stuck in a loop where it just repeats this part a few times. And I think that'll help this buzzer out quite a bit. So we've seen this before. We're going to make x equal to, say, 0. Make sure you use a semicolon right there. And then we got to set up a little statement that when it becomes falsified, then we're kicked out of our loop. So let's just say x is less than 100. So this will put us through this loop 100 times. And then let's go to what's going to happen as it goes through each loop. We're going to slowly increase the value of x. So once it's greater than 100, then it'll jump out of this loop. Now these delays are really tiny, so they're not going to be in there very long. Normally going to 100, you might think that would take a little while. Actually, I don't know why I have semicolon there. We need to have a bracket, because everything in our bracket is what's going to be repeated. All this repeated over and over again as this thing counts up from 0 all the way up to 100. It'll just keep repeating, turning this high and low, and that's what we need to get this vibration going. Alright, so let's pause there and give this part a try. So we'll upload. Waiting over there. Looks like we're done. Let's open the serial monitor and let's put in for our user input. Now our user input is for microseconds. Let's just do 1,000. See what we get. Well, that was interesting. It actually was not what I was expecting. We'll try 2,000. Okay, the sound quality, as you notice, was significantly better than the last time. Before it was really quiet and really short, and this time around let's do 3,000. The pitch is obviously changing. I don't know how well you can hear that on my microphone, but the pitch is obviously changing as I increase this from 1,000 to 4,000. And see how nice it is to have this part up here that I can immediately just change my user input just by typing the number in up here instead of having to reload the program every single time. Adding a little bit of work up front makes our job a lot easier. So we're able to change this pitch nicely, and the sound is a little better quality. It's not lasting as long as I would have hoped for. I would want to show you one more thing. Let's throw in here, just for giggles, because this will make my point more than anything else I'll do. Put in a little serial print statement where I want to show us, first off, that's actually going in this loop, and I want it to print x out. So x should be going from 0 to 100. Each time it goes through this loop, it'll go this line first, it'll put a 0 in here, then it'll go through this. And say, okay, this is still true, so I'll add a 1 to it. Now it puts a 1 in here, and then goes through here again. And we should see this value for x being printed every time we go through this loop. So I wanted to actually see that as it's occurring. Alright, let's upload this. Maybe we'll take a little cat break. Alright. It's done. My monitor must already be open somewhere. There it is. Alright, I assume everything looks good with the monitor. Let's put in 1,000 again. Alright, so as you can see with all these numbers here, it is going through this 100 times. Now it's 99 here, but we started on 0, so if we add that extra 1, that would be 100 times. But since we're using microseconds, it's going super fast, which is great for buzzers because they want to be vibrated on and off really fast, particularly this one without the sticker. Let's do 3,000. Now it's on a little longer because it's having to print this out is slowing things down slightly. Let's do 4,000. Nice. So this is working quite nicely. And you'll notice it's fairly simple code and certainly a very simple program. And the build is actually simple too. That's what I meant to say. Let's pull this one out and let's look at this other one again. You don't want to ignore it. There we go. And let's give this one a try. This one did not have much trouble with. Alright, this guy is a little unhappier. Do 3,000. Sounds a little worse. Sounds like it's got a cold. And I don't hear any change in pitch anymore. As I'm going up, I'm not really hearing much of a change anywhere. So using digital right and using these microseconds is making this buzzer sound like it's got a cold, but this one loved it. So I'm just trying to point out some of the differences between these two. And I also want to show you one more thing. Let's get rid of that. And I think we've seen this. Hopefully you understand what it is I'm trying to show you here. We're just simply turning this on and off really fast. We can controlling how fast we turn this on and off is allowing us to get different pitches with the one buzzer quite nicely, and the other one is not as happy with it. And this part was just so we can control what's happening a little better. Now there's an easier way to do all this, and I want to show you that before we leave. So this is sort of a easy to understand way because we've done this with LEDs. This other way, we're going to get rid of some of this code. Let's get rid of all of that. And we're going to use another statement here called a tone. And in this tone, we're going to be using, there's 3 parameters, and we're going to mention just 2 for right now, then we'll talk about the third one in just a minute. First one is the pin that we're using, that the buzzer is connected to. And so we're using pin 2. As we saw up here, and on our build, we're plugged into pin 2. The next parameter, next thing we need to put in the parentheses here, is the frequency that we want to enter. And so let's just start off with, actually, let's use the code that we have, and let's use user input. So we can manually just put in values for this. Alright, to user input. So whatever we put in is going to be put in as our frequency for this tone. So let's give that a try. We got time for a cat. I think we got time for a cat. Let's do it. Alright. Let's do 1,000. Okay, well, there's 2 things. One is this thing doesn't stop. And that's because nothing told it to stop. And this is going to get very annoying again. So I want to show you how we get this tone to stop. I'm going to, for right now, unplug it from the ground. Let's actually fix that now. Let's do it again, and then we'll talk about one more thing. So once we're getting input from the user, and we're putting that into this variable user input, It's just staying on. There's nothing in here telling it to turn off. And the other one we were doing digital write high and digital write low, and the low was turning it off. So we need a way to turn this off. So the other little line of code, which is simple, kind of makes sense. No tone is not changing color, so it must be capital T. There we go. And in here we got to tell there's one parameter, and that is what pin are we using, which one do you want me to turn off. So no tone will turn this thing off. And if I just do this, I'm trying to remember, yeah, what's going to happen if I just do this? How long will it stay on? There's a third parameter in here. We can control how long it stays on, but I'm actually just curious. I don't quite remember. Let's do a little experiment for Mr. Brower here. We'll just run through this so fast we won't hear anything before it turns off. I am curious. I'm going to predict that it's going to go by so fast from this line to this line that we won't hear anything without a delay. But I'm going to do 2,000. And we did not. We did not hear anything. We went from here to here. Let's double check. Let's go 3,000. Alright, so in between these, we want to be on a little while so we can hit delay, say 1 second. So we're going to hit that tone, let it be on for 1 second, and then we're going to turn it off. Alrighty, there we go. Let's do 2,000. And I still don't hear anything. I gotta squeeze that cat some more. Come on, cat. Give me some coding power. I keep doing this twice now. That's cool, though. I keep leaving that ground out. Alright, well, that's fun. So I'm going to go back and finish my experiment. I'm going to go back and leave that out because that wasn't the actual experiment there. Now it's Mr. Brower not getting enough cat power. I need a few more here. Alright, I think I'm ready. And alright, back to our experiment. 2,000. I still don't hear anything. Okay, so the conclusion is the same. Let's actually do 3,000 just to be sure. Alright, it's running right through those and nothing's happening. And it is plugged into ground. Alright, now let's get a delay. Back to 1,000. Upload this. I think my problem, actually I know my problem is I actually need my little dino friend energy here. Bam, now I'm ready. Okay. Let's do 1,000 again. There we go. Lasted for 1 second. Sounds nice. I hope you can hear those. Ooh, that was a little bit rough. Wow, that probably is making your dog real upset. Okay, so it looks like it's happy between about 2,000 and 5,000. And where's another way we can do this? We actually don't need a write delay in here because that third parameter I was telling you about, how long we want this on, is actually here, and we could just put that right here as 1,000 and it'll do the exact same thing. So let's upload that and give that a try. Okay, let's do 2,000. Nope, I heard nothing. What's Miss Brower doing? 3,000. Well, that is weird. I'm going to switch these. Oh. Why is it not giving us the delay right there? Well, all else fails, we can go back and put the delay in. between tone and no tone. I'm curious though. My instinct though was to switch this, and I wanted to try this anyway and see how the other buzzer was going to do with this new statement in here. So we don't need to upload anything, we're just changing parts out. And let's go back to 2000. Oh, I just heard like a tiny little click. Tiny little click again. Wow, I know you probably can't even hear any of that, but it's just a tiny little click. So let's go back. Let's go back, since we're not having much success with that, and just leave the delay as 1000 for 1 second. And I wanted to hear what that sounded like with the other buzzer. Okay, uploading. Done uploading. Ow! Just kind of going up to scale here. And let's try 1000. That's the loudest right there. Okay, anyway, so we've toyed around with both these buzzers, and we're getting, as you can see, slightly different qualities of sound depending on what type of code we used. I don't know per se which one's better or worse, but we have some options we can do. We can use this tone, or we can use the turn it on and off rapidly technique. And just for giggles, I still want to try this one last time. I want to try this one last time. I haven't given up on you. Third parameter, let's... Okay. No, just back to that weird little barely audible click. Let's switch back to the other one. I like to know why things are doing what they're doing, so I just tend to pour time in to stuff just because I'm curious. But this one looks like I'm going to have to mess around with on my own time just a little bit. Alright, so that looks pretty good. Now of course the top 3 lines here, if we don't want the user input, we could actually just get rid of all these. In fact, a nice variant of this project would be to get you to pull out your potentiometer and get rid of this part right here, but use the turning of that knob to change the sound of our buzzer. That'd be a good project for you. So we wouldn't need that. We wouldn't need this up here unless we wanted to. I like having this because I can use it to figure out what's wrong with my code if something's not working right. But technically, if you're doing the potentiometer, you can get rid of that and then just type in one line is all you would need, and then use that as our input. So if you want, you can give that a try. Otherwise, we are done for buzzers. We're going to use buzzers in one of our future builds, so they're not going to go away. They're kind of fun. So I hope you enjoyed working with buzzers today. We'll see you later.